For this video, I'll explain the top-down approach and the bottom-up approach to solve the Fibonacci series. The bottom-up approach is the dynamic programming approach, and the top-down approach is a non-dynamic programming approach. I've already pasted the code for the top-down and the bottom-up approach. Approach, the Fibonacci of n is equal to 1 if n is less than or equal to 1. Otherwise, there are two recursive calls to calculate the Fibonacci of n minus 1, so it's just a call here, and a Fibonacci of n minus 2, and then an addition. So this one and this one, so it's just a split of nodes if I have one node. So if this is n, this will be n minus 1 and n minus 2. Again, this will be split into 2. And in the bottom up approach, I just have a for loop. So initial conditions is Fibonacci of 0 is 1 and Fibonacci of 1 is 1. So something like a table with Fibonacci of 0 is 1 and 1 is 1. So this is the initial condition, and from 2 to n, it's just the previous, so previous one plus the previous of the previous one. So these two, if you add, you get the Fibonacci of 2, something like that. 1 plus 1 is 2. So that's done here. I'll take an example for both the approaches. So I'll clean up this one. Okay, as an example, I'll calculate the Fibonacci of 5 using the top-down approach. So Fibonacci of 5 is nothing but Fibonacci of n minus 1. So Fibonacci of 4 plus Fibonacci of n minus 2. So 3. So initially 4 is called. So let's continue with 4. So Fibonacci of 4 is nothing but Fibonacci of 3 plus Fibonacci of 2. Fibonacci of 3 is Fibonacci of 2, and Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 1 and Fibonacci of 0. So Fibonacci of 1 is 1, because if n is less than or equal to 1, then return 1. So if 1 is equal to 1, so return 1 here, and 0 is less than 1, so it's 1. So we have one addition here. 1 plus 1 is 2, and Fibonacci of 1 is 1. So 2 plus 1 is 3, and then Fibonacci of 2 here is again Fibonacci of 1 and Fibonacci of 0. So it's again 1 plus 1 is 2, and then Fibonacci of 4 is 3 plus 2 is 5, and then for Fibonacci of 5 we need Fibonacci of 3 again. So it's 2, Fibonacci of 2 and Fibonacci of 1. So Fibonacci of 2 is need more space. Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0. So Fibonacci of 1 is 1 and Fibonacci of 0 is 1. So it's 2, 1 plus 1 is 2, and Fibonacci of 1 here is 1. So 2 plus 1 is 3. So Fibonacci of 5 is Fibonacci of 4 plus Fibonacci of 3. That's 5 plus 3 is 8. So we see that we reach from the top to the bottom to get the solution, and we have lot of sub problems like 2, Fibonacci of 2, Fibonacci of 3. All these are sub problems, and we have repeated sub problems that we have solved every time. So we have added 1 plus 1 to get the Fibonacci of 2 here, and again 1 plus 1 to get the Fibonacci of 2 here and here. So with top down approach, we just split the node into 2 until we reach Fibonacci of 1 or Fibonacci of 0. That's n is less than 1, we just give the answer, otherwise we split the node into 2, something like this. So using bottom up approach, if we want to calculate the Fibonacci of 5, it's quite different compared to top down approach. Here we actually start with the node, the smaller nodes, and then reach to the solution. So initial condition is Fibonacci of 0 is 1 and Fibonacci of 1 is 1. So that's here. And then for I is equal to 2 to n here is 5 for us. So we move from 2, 3, 4, 5. So we calculate the solution for 2 and then move to 3. So it's Fibonacci of 2 is 2 minus 2 is 0. So 0 and 2 minus 1 is 1. 1 plus, so we add it, 1 plus 1 is 2. And then we go to 3. Fibonacci of 3 is Fibonacci of 3 minus 2 is 1, and Fibonacci of 3 minus 1, that's Fibonacci of 2. So 2 plus 1 is 3. And then I is incremented to 4. So Fibonacci of 4 is equal to Fibonacci of 4 minus 2, that is 2. So if I consider Fibonacci of 4, Fibonacci of 2 plus Fibonacci of 4 minus 1, that is 3. So Fibonacci of 2 plus Fibonacci of 3 is 2 plus 3 is 5. And then I is incremented again, and now I Fibonacci of 5. Fibonacci of 5 is Fibonacci of 5 minus 2, that is 3, plus Fibonacci of 5 minus 1, that is Fibonacci of 4. So 5 plus 3 is 8. So it was clearly a bottom up approach. We started with the initial conditions and reached the solution of Fibonacci of 5 is equal to 8. In the top down approach, we started calculating from Fibonacci of 5 and then split the solution into sub problems, and then finally reached the end nodes, and then we again moved up with the solutions. So if we calculate the number of additions we did using the bottom up approach, it's 1, 2, 3, 4. So number of additions with bottom up approach is 4. And then in top down approach we had 1, 2, 3, 4, 5, 6 and 7. So number of additions performed, number of additions here in top down approach is 7. The main reason is because we have calculated the Fibonacci of 2, for example, for 3 times, and Fibonacci of 3 twice. So we have calculated, we have split the problem into sub problems, and few of the sub problems we have calculated it more than once. But in the bottom up approach, we started with the sub problem and then we only calculated the sub problem once. So if you see this how we reach the solution, we can, in the bottom up approach, it's almost like creating a table. With initial conditions, Fibonacci of 0 is 1 and Fibonacci of 1 is 1. And then for 2 to 5, so I'll calculate Fibonacci of 5. So calculate Fibonacci of 5. So 2 is 0 Fibonacci of 0 plus Fibonacci of 1. So it's this. so it's 2. And then Fibonacci of 3 is Fibonacci of 1 plus Fibonacci of 2, that is 3. And then Fibonacci of 4 is Fibonacci of 2 plus Fibonacci of 3, is 2 plus 3 is 5. And Fibonacci of 5 is Fibonacci of 3 plus Fibonacci of 4, that is 8. So the previous two solutions were used to calculate the Fibonacci of 5, Fibonacci of 3 plus Fibonacci of 4. So if we look at the overall picture of the dynamic programming approach, the picture we made at the start, at the beginning, we have a problem, for example Fibonacci of 5, we had overlapping subproblems, Fibonacci of 0 and Fibonacci of 1 was equal to 1, that was our initial condition, and the other subproblems were Fibonacci of 2, Fibonacci of 3, Fibonacci of 4, so this was equal to 1 plus 1, that's 2, and then Fibonacci of 3 is 2 plus 1, 3, and Fibonacci of 4 is 2 plus 3, 5, and then Fibonacci of 5 is equal to 5 plus 3, 8. So we had subproblems which we calculated the solution only once. So if we look at the bottom-up approach, we had calculated the solution for each subproblem only once, and then we had recorded it in a table. So if you see the program here, we have used an array in which we have saved the solution for each iteration. So it's something like this. So array from 0 to n. So 0 and 1 is the initial condition, and 2 to 5, that's n, is in the for loop. So it's a one-dimensional array, it's a table. So we recorded the solution of the subproblem in a table, and then in this case the last element was the solution which was generated using the other elements of the table. So that was the solution of the whole problem.